Hello everyone, hope you all are doing well. In this video, we'll discuss the second problem of Leetcode Weekly Contest 291. The problem name is minimum consecutive cards to pick up. So the problem says that we are given an integer array cards where cards of I represent a value of the ith card, and a pair of cards are matching if the cards have the same value. So this is what we mean by the cards and the matching value. We need to return the minimum number of consecutive cards that we have to pick to find a pair of matching cards. So, and if it is not possible to do that, we return -1. So, given the array, we need to pick up some elements, some consecutive elements, so that we are able to find a matching element, a matching card in this case. And out of those subarrays which fulfill this criteria, we need to find the length of the minimum subarray. So if we look into this example, so it says that we can pick up the cards 3, 4, 2, 3. That is this subarray 3, 4, 2, 3, because it has a matching card of having value 3, and the length of this subarray will be 4. The second possibility is that we can pick the values 4, 2, 3, 4. In this case, the matching card is 4, and again the length of the subarray in this case is 4. So both the cases are resulting in the subarray length being 4, so we return 4 as the answer. If we look into the second test case, so it says 1053. So we see that uh, no element is repeating. That means we can't find a matching pair even if we pick all the cards. So we return -1 in this case. So yeah, this is the problem. Let's see how we can approach it. So suppose we are given an array. Suppose we have an array. This is the array. Yep. Yeah. And suppose we have some values, like for example, we have a value 3 here. We have a value 3 here, and we have a value 3 here. Forget about the other values. Let's see that what will happen when we have a value, when we have the same value at certain indices. So let's assume currently that value is 3. So as so when we start traversing the array from the left side, so as soon as we encounter a value, in this case let's assume that's 3, so we can check that whether the value 3 is present on the left side of this index or not. Let's assume this index is I. This index is I. So if there is a 3 present on the left side of this index, that means we are able to find a matching pair. The matching pair will have the uh, last last index as this one, and starting index as one of the possible values on the left side. So that could be a certain index. So in this case, we see that this is the first element, and we are not able to find a matching pair for this value 3. Now let's move forward. Now as we move to this index, let's call it j, we see that we have a 3 here. And for this index, we also check that whether have we seen a 3 on the left hand side of this index j or not. Now yes, we have seen it. How we will know that we have seen or not? We can use a simple hash map in this case, that we can keep the indices. What was the last? What is the, I would say, the maximum index for a particular value that we have seen. So we'll see what that means. So for this particular j, we know that okay, we have an index I. So that means we found a matching pair. Now what will be the length of this subarray? It will be j minus I plus 1. So that means this subarray will have length j minus I plus 1. Now all we need to do is that we need to compare it with the answer that we have seen till now, and if this value is a smaller one, we just need to assign it to the answer variable. Now let's move further to see one more thing. Now after j, we keep on moving forward, and suppose we find 3 again at index k. So this is the index k. Now again, we know that we have seen 3. Now, what are the indices at which we have seen 3? It is index number 1 and index number I and index j. Now, if we see here, then if we consider the index k in our current subarray, then the only relevant index for us is j to make a pair with k, because j and k will return us a length which will always be less than the subarray which we will make using k and I. So there are two possibilities of making subarrays having matching pair with a value of 3. Those two subarrays are subarray with k and j and subarray with k and I. Now we can see that the subarray jk will always have length less than the subarray I comma k. So that means this is discarded, and same is true for all the indices of 3 which are present before I as well. So that means for every particular index we just need to calculate the value using the latest index of this value that we have seen. That means the latest index value of 3 in this case. So we just do k minus j plus 1. In this case, this will be the length of the current subarray. So that means now if you look into the main algorithm, so we need to traverse from left to right, and for every value we need to see whether we have seen that value till now or not. If we have seen it, if we have not seen it, then we'll just add it to our map, that okay, this map v comma I, and if we have seen it, then what we'll do, we will calculate, we will fetch that value and we'll calculate the current length that will be equal to index number I minus map of get v, sorry, get v. So this will be the current length, sorry, plus 1 as well, yeah, this will be the length. Now when we do this, we update our map. Now the map will have value v comma the current index, again v comma I, because we saw that only the latest index will be relevant. So once we calculate the length of this subarray j comma I, so we will update the map with the latest index of 3, so that when we move forward and we encounter a value 3 again, we compare that index with jth index, and not the index beyond this one. So that's the main logic that we will be using here. And let's look into the code, uh, how we will write the code for this one. So again, it's a simple one, implementation based problem. Um we come here, we declare a map here, and again answer variable has the max value, again just for initializing purpose. We start traversing the array and we see that whether our map contains this value or not. That means whether we have seen this value till now or not. If we have seen, then we calculate the minimum value among the ones that we have seen till now and the current one that we are seeing. That means the current index minus the index of cards of I, the latest index of cards of I. So this this will be the answer. This will be our updated answer, and then we update our map that now the cards of I will have value I, so that when we move forward, that particular index is compared with the current index. That means the ith index. So we do it for each and every value. We keep on updating the answer, and at last if we have answer equals to integer dot max value, that is the value that we initialized in the beginning, then all we need to do is that we need to assign -1 to it, because we are not able to find a possible pair, and then we return the answer. So again, an implementation based question, and the time complexity for this one is big O of n, and space is, if you see, then it's big O of number of distinct values that we have in cards of I. So hope you learned something new from this video. Do support it by giving up a thumbs up, and do subscribe to the channel. See you in the next video. Thank you. Thanks a lot.